Hi guys, welcome to our video on conservation of mass in Unit 4. You'll need your notes, which is your pen and paper. So here we'll track what happens to mass in the reactants versus the products and discuss conservation of mass. So here we have a chemical reaction occurring. We're going to add water to Na2CO3 of sodium carbonate. So before we even do this reaction, we want to take the mass of each of our reactants. We have our water and our sodium carbonate, and they're each in different beakers. We know that the beakers themselves will actually have mass, so we want to make sure that if we have the same beakers on the reactants, or before we do the experiment, we have the same beakers after we do the experiment on top of the scale. So the mass of the water plus the sodium carbonate is 125 grams. When we do the reaction, so when we add the water to the sodium carbonate, we still end up with 125 grams. So here, this is the conservation mass, where the mass of the reactant should equal the mass of the products. And here, in this case, we have hydrochloric acid and magnesium, and we're going to see what happens when we put them together. So beforehand, we have 151.00 grams of the reactants, and at the end, we have 150.50 grams of the products. We've lost half a gram in this when we're doing this. So, if we take a look at what actually has happened, or in the chemical equation, we see that H2 gas is being produced at the end. Gas does have mass, as we've seen in Unit 3. So when all of this gas starts to bubble out, what's left is magnesium chloride, the aqueous magnesium chloride, which actually has, which is going to show the lesser mass than the reactants. We could actually go ahead and collect that gas, that hydrogen gas. If we did and took the mass of that, it would actually end up equaling the 151 grams that we had originally. So here we have sodium chloride and silver nitrate produces sodium nitrate and silver chloride. So if we take the mass of the reactants, 58 grams plus 170, it equals the mass of the products, which is 85 grams and 143 grams. So when we add the reactants together, it should equal the mass of the products. Sometimes you'll have equations like this where they'll tell you what the mass of one of the reactants is and the mass of the products, and you have to figure out what the other one is. So in this case, they might have made this x. So you've just made this 58 plus x produces 85 plus 143, and then solve from there. So here, again, we want to show that we have the mass of the reactants equal to the mass of the products. So we have calcium carbonate. 50 grams of that produces calcium oxide and CO2. So we show that the CO2 is our unknown, or our x. So we have 50 is equal to 28 plus x. So then I go ahead and solve for x. When we do that, we end up showing that we have 22 grams of carbon dioxide. And I don't know why it disappeared, guys, sorry. But this ends up being 22 grams. So the conservation of mass is that mass can neither be created nor destroyed in a chemical reaction. We've seen this statement before. You've probably heard this statement before. But when we do this in an equation, we show that we actually have the same, the mass of the reactants is equal to the mass of the products. A common Regents question is asking the conservation of the following things. So they'll give you this in multiple choice, for example. And which of the following shows conservation in a chemical equation? We'll actually show that it's charge, energy, and mass. Sometimes it won't always be this energy, or this order. Sometimes it's like mass, energy, charge, or energy, mass, charge, or whatever. But I kept it in this order for this reason. The CH of the charge, the E from the energy, and the M for mass spells out chem. So the way for you to remember what there's a conservation of is just by remembering chem, charge, energy, and mass. So to summarize, the law of conservation of mass shows that the mass of the reactants is equal to the mass of the products, and whenever we're asked in a Regents question what there's a conservation of, it's always going to be charge, energy, and mass. Have a great day, guys.